Welcome student to the fourth lecture of logic and distributed control system, and today we are going to discuss about the last part of distributed control system. So last lecture we have discussed about the three architectures, that is hybrid architecture, central computer architecture and distributed architecture, and we have understood that what are the advantages we will get from architectural point of view about the DCS. So this thing we have studied in the last class. So today we are going to discuss about the hardware and the hardware components are required for a distributed control system, and also we will understand that how the signal is going to flow through the hardware in a DCS. So as an introduction, we can say that in any process plant, the purpose of automation to maintain the product quality, consistency, reduce startup time and increase speed of operation with human safety. Control system, whether it is a programmable logic controller or it is a DCS, is required for the same purpose. So purpose is to automate the plant. The concept was accepted throughout the world as the whole production process was not affected by the failure of one card or chip. Distributed control system, which is better known as DCS, comes into the action henceforth, and there are 50 modern distributed computer control system in the market today, and some of the companies or vendors are enlisted and their typical name of their DCS is listed here in this table. So here we can see that this Honeywell TDC 3000 and the Honeywell TPS system, they are very popular amongst the industries. The system have been introduced only a few years after the first distributed control system, that is Honeywell's TDC 2000 system, has been installed. And if any industry, big industry, if you visit, you will find that either the Honeywell DCS made by Honeywell or Yokogawa you can observe, or ABB. Also you can see that another leading company is ABB. Other than that, many companies are there or vendors are there. They have the DCS, they are the DCS manufacturer. So now we want to understand that how the DCS is functionally and physically distributed. Based on the process requirement, distribution is classified into functional distribution as well as physical distribution. So first we want to understand how it is functionally distributed. So when the distribution is made depending on different functions of the control system, then it is called functional distribution. The block diagram of the functional distribution is shown here, where we can see that main 6 components of DCS is present. What are they? Now, operator station, mass storage devices, special function modules, process connected controllers and interface to foreign devices, along with the communication link. So these are the 6 major components exist in any DCS system, distributed control system. So what is the use of operator station? Man machine interface, process control and operation, system configuration and engineering functions, alarm displays and self diagnostic displays. Then another component is the mass storage devices. What is the use of it? The system data storage, historical data storage, special event storage. And another module is there which is called special function modules, which is used to execute the application specific programs. And another very important module is their process connected controllers, which is used for IO monitoring, input output monitoring, regulatory control, sequential control, logic and logic control, which may be the PLC. And the interface to foreign devices, another module is there which is used to interface with the foreign devices, that is used to gateway, that is used as a gateway to various PLCs, computers, special purpose controllers, other systems, etc. So you see here the components of DCS which having different functions, they are distributed, not a single computer or single device is going to execute the whole job. The total control functions along with other functions are distributed by several modules. And what is the meaning of physical distribution? Now, when the distribution is made depending on the different works in a plant based on area, then it is called the physical distribution. The plant is divided into different areas. Now each area is again divided into several groups. The wiring of each group is connected to a card, maybe 1, 4, 16, 32, 64, 28 number of wires, depending on how many inputs and outputs you have, depending on the physical distribution of the process monitoring, measuring sensor, transmitter or final control element in a process. Logical groupings of 6 to 12 IO cards through field junction boxes are well accepted in the present trends. Now, pictorially it is represented. You see the whole plant is divided into several areas: area 1, area 2, area 3, area X. Now, depending on the input and output devices present in the area, the grouping can be done, and group can be done with 1, 4, 8, 16, 32, 64, 128 number of IOs, and these IOs are connected to the IO card. So now from here it is very much clear that if any card fails, then what will happen? Only a group will be affected, not the whole plant is going to be affected. But here one thing has to be understand, though the functions as well as the physically it is distributed, but it is monitored centrally. That is the very important features of a DCS. So now, advantages of physical distribution: the whole process is divided into different areas, so better maintenance of each area, better control can be done, which will lead to enhancement of the production. The concept of local area network comes into action, where the networking is done only on a particular area so that the control becomes easy. There is also higher availability of redundancy. If one card fails, only a particular group is affected and thereby not disturbing the other operations undergoing in other groups. Each area is again interconnected with other areas at digital communication level of DCS. Monitoring and control of an area from other area is also possible. Now, next issue we are going to discuss how the DCS is working. The working of DCS can be divided into two parts. First, we will see the hardware flow, then we will see the software. In any process, the sensory organs of a process are sensors and or transmitter through which the status of the process is known. The flow of the signal from the sensors transmitter to a local field junctions box where number of wires comes. So now pictorially just you see it. So we have the process, follow the blue lines. So depending on the area, several input devices will be there, means several sensors will be there, maybe the flow sensor, temperature sensor, the level sensor, pressure sensor. So these inputs are measured and it is flowing and coming to the field junction box, okay, in a group. So now the flow of signal passes from sensor transmitter to a local field junction box where number of wires comes. From field junction box through a multi-core cable, it goes to the main junction box. So now from this this group of signals or group of wires coming to the main junction box through multi-core cable. Again, from the main junction box, it comes to a marshalling cabinet where the wires enter into the control panel. So now the signal is going to the control panel through the marshalling cabinet. So after entering to the control panel or DCS panel, the controller and IO cards are placed, where the IO card inside the control panel or DCS panel, IO cards are placed. After signal entering the panel, the signal where with or without a relay card goes into the input card connected to the controller. So before going, it is not going to the signal which is coming from the field is not directly going to the DCS controller, it is going through the input cards. Now controller thereby possesses the data according to the logic created and gives output to the final control element through output cards following the same route. So now what will happen, whatever the data is given to the controller, and we have written some program inside the controller. Based on this data, the controller is updated and control signal is generated, and the same path it is going to flow and coming to the process. So this is the signal flow, and the hardware hardwares are related with the DCS. Now another way it has been shown that how the control is distributed, but it is monitored centrally. So inputs from the fields are coming from as a group. So the control functions are distributed where several set points are given. So FCS1, FCS2 field called, this is called field control station, FCSN. Now they are producing locally the control variables, and that control signal is going to the field. So that's why it is written outputs to the field. But though the function of the controller is distributed, but they are monitored centralized, because with the communication bus they are connected to the HIS engineering and HIS operators. Okay, so this is the human machine interface what we have, through which the monitoring can be done. Now for the software part, there is a scan cycle which needs to be completed for the execution of an instruction needed to control the process. The scan period is set by the user while configuring DCS, and the following steps occur for each scan period. What is that? What are the steps? Now, first, the status of inputs from the process through the input cards are checked. Then the values are updated in the program, and according to the logic prepared by the programmer, output values are decided. These outputs then go to the field through output cards. Moreover, the status is updated in the SCADA, as well as all the changes are stored for the future reference in the historian. Any alarms, that is deviation in the process, are there, then they are also noted and stored. So this is the software part exists in DCS. Now a typical cabinet, DCS cabinet is look like this. If you visit any of the process control plant in a control room, you can see the DCS cabinets are there, and this is a typical picture of a field marshalling. And now the functions of DCS are stated. What are they? Now, IO signal characterization, signal filtering, alarming IO modules, ranging and engineering units, control logic, control interlock, sequencing, batch control, passing on trending information, passing on report information. So these are the typical job or functions of DCS. Now at last we are going to summarize the advantages of DCS. System implementation can be carried out in a modular fashion, due to which system growth can be easily achieved, as each processor has clearly defined set of functions if carefully designed. System overloading is less in case of DCS. In case of failure of a part, DCS does not affect the whole system or processes. Backup functions is there, that is redundancy features possible in DCS. Reliability of DCS is more than that of the centralized control. Reduction of cost of interfacing to computer due to reduction in wear uses for control purpose. DCS is more flexible in terms of altering the configurations within a specified range so as to conform to the change requirements. If any, duplicate storage of critical data can be done easily. Independent and standalone processors communicate with each other, which make management of computers easy. Minimization of data loss as well as the errors due to the placement of controllers in the nearby vicinity in DCS. Advanced control strategies are easy to implement in DCS, and some limitations are also exist. What are they? The cost is high when compared with PLC PC combination. Specialized support from engineering personnels are required. DCS require a clean control room environment compared to the PLC or PC environments. So This the lecture about the 1, 2, 3, and 4 we have devoted to understand the advantages and disadvantages of DCS, also how the DCS is functionally distributed and physically distributed, and then we have understood the architecture of DCS. And now also we have understood in DCS how the automation is achieved, because hierarchy of control is also exist in the DCS. So this is the all about the distributed control system, and from the next class we will start to understand the architecture of PLC or the components of PLC, and slowly we will try to understand what are the programming features are available in PLC. Thank you.